Okay, next up we have Chris Carberry, who's the Executive Director of Explore Mars, and their mission is to encourage the human exploration of Mars. Yeah, I will do that for you. So that's why I came up.
Okay, well, thank you, and thank you, Vin and Mike, for having me come. As Mike mentioned, I'm Chris Carberry, an Executive Director at Explore Mars. Explore Mars is a nonprofit 501c3, and as the name would imply, our goal is to advance the goal of human and robotic exploration of Mars. And of course, Mars has come up quite a bit during this discussion here, and I was happy about that. And actually, it's come up in some very unexpected places as well. So I was actually happy to hear it in the Teachers Without Borders presentation. Very amazing that they're already made the progress to start thinking about what's like on Mars and the geology on Mars. So I found that very pleasing. But this conversation we're having here today is very relevant to Mars, however, because, one of the things, particularly if we send humans to Mars, we need to really improve the communication backbone in deep space networking. But I'm going to talk about kind of the broader message here. When will humans land on Mars? And this is not lining up very well. I'm not sure if we have a solution for that, but let me advance ahead. So our organization, basically, we run programs, we run policy work, STEM education, and we're about to run very shortly, some technical projects, which are very relevant to some of the discussions here. We'll get to that at the end, but I apologize in advance if I'm going to rush through some of these things, because only 20 minutes to start talking about it. So, well, at least you can see the bottom of it right here. So one of the primary reasons, and I'm only going to talk about really two reasons, I could talk about for hours why we should go to Mars, but one of the key reasons is this stuff right here below the Phoenix lander, water. There is a lot of water on Mars. We've discovered it all over the place. This one was actually rather amazing. When the Phoenix lander, I don't know how many, probably most of you are familiar with it, but when it landed on Mars, they had this scooper that was going to dig down looking for the water on Mars. And it turns out the water ice was so close to the surface, the retro rockets actually cleared the soil and exposed water ice. They looked all around, and they looked underneath the spacecraft, and they had discovered water. They didn't even need the scooper. So that showed that there's an extraordinary amount of water ice on the planet. There's also a strong history of former, running water, rivers and lakes and ocean bed. You can see from orbit, just amazing amount of water ice from orbit. And we're kind of falling off here. And let's see, in this one here in particular, there's also strong evidence of actual liquid water below the surface on Mars. Why is this important? Every place on Earth where there's water, there is life. And so Mars, because of that, it's the closest place that humans can actually go, where we might actually find strong evidence, or we may actually discover life on another planet. There is a growing body of evidence that there is actually life on Mars. Microbial life, subsurface life. But if there is subsurface water, that increases the odds dramatically. But in addition, he didn't put the last slide in, but in addition, this is also important for another thing. If we send humans there, water is extremely important for obvious reasons. So for these two reasons, these are strong reasons to go. I mean, humans are much more likely to find a life if we're there, but we can also go to Mars because of the water, because of the atmosphere and other resources there. It's the best destination for humans to go and be able to live off the land. The moon, you can do it to some extent. There are advantages to the moon because it's closer. But Mars really has a lot more going for it with the water, so we can actually manufacture fuel and oxygen by accessing the water and the CO2 atmosphere if you have hydrogen along with you. So there are lots of really strong reasons to go. In addition to the building evidence of life, we've also discovered other things such as unexplained methane on Mars. And this keeps going back and forth. We've observed it from telescopes and other resources. So far, the Curiosity rover, which is currently there right now, hasn't found evidence of methane, but we have seen plumes of methane over the past few years which can't be explained. The only reasons we know methane would be there is because either geological activity that we're not aware of. Ah. Or life. You know, here on Earth, life accounts for most of the methane on the planet. So I'll just
Right there.
PowerPoint. Yeah, that would be
33 minutes.
That explains why we couldn't find the.
There you go.
Ah, much better. I'll just shoot through here. So when are we going to, I'll just skip ahead a bit. When will we actually get to Mars? Current policy is, right now, roughly speaking, the current policy set by the administration and NASA is the ultimate goal, ultimate destination is to get to Mars by the 2030s. Except it's not very well defined. We haven't defined when, how we're going to get there, really what we're going to do, that we've talked about doing a flyby in the mid-2030s, and a bunch of other things, but our policy hasn't been really defined. So without more definition of the policy, we're never actually going to do it. However, there is a growing, because of all the discoveries we've been making, and plus some additional progress with commercial sectors, and as well as a lot of new work by companies like Boeing, Lockheed, Aerojet, and others, there's been a growing consensus. Things are shifting back towards Mars. There is a lot of enthusiasm. And this was highlighted in a recent activity we did, if I can actually get to it. Great pictures, though. I mean, that's a crater on Mars, Victoria crater. There was my methane slide. It wasn't on the PDF. All right, we've been, you guys, oops. And this isn't a new dream either. We've been talking about this for a long time. It's kind of funny. I was in a policy meeting the other day in Washington, and they said, what's the hurry? Why do we need to get there so quickly? I was thinking, well, first off, I wouldn't say 20 to 25 years is rushing, but this is 50 or 60-year-old, idea. Wernher von Braun was talking about this seriously in the 50s and 60s, and NASA was really planning on it. They were hoping to get to Mars by the 80s. We missed that goal. Since then, we've had quite a few plans. Back in 1989, George H.W. Bush gave a speech saying we wanted to get to Mars in, I believe, 20 or 30 years. It was the space initiative, except when the plan came back, it was ridiculously huge and expensive. It was basically lining the pockets of probably every congressional district. So it was just, I would have voted against it as well. But then, after the Columbia accident, George W. Bush, of course, rekindled the dream 15 years later with the vision for space exploration. But, of course, once again, that plan was scuttled. And President Obama, once again, also talked about Mars being the ultimate destination. Yet, we haven't moved forward. So, last month in December, we Explore Mars and the American Astronautical Society pulled together a group of stakeholders, including NASA, Boeing, Lockheed, Aerojet, and many of the people in science and academia and policy, to try to harness this growing interest within the community and within policy circles to do this, to get everybody on board and agree on certain principles. Specifically, that affording Mars, Mars is affordable. Now, affordable is a tricky term. Affordable for one person is very much not affordable for others. But we got the group to agree that we can do this feasibly and affordably without raising NASA's budget dramatically. It wouldn't be a sequestration budget, but we can do it with roughly the same amount of budget as long as we had increases for inflation by using an incremental approach. It's technologically feasible. This group also agreed, and this was a diverse group. It wasn't just a group of Mars folks coming together and saying, yes, we believe we should go to Mars. This was a very diverse group, and they believed it should be the overarching goal of the U.S. space program over the next 20 to 30 years. That doesn't mean we shouldn't go other places, but we should use Mars as the framework in which we design missions, that they advance, they actually contribute to the next step. So we're not just going and hitting a roadblock, stopping at the moon and staying there for 50 years. The moon can be part of it, asteroids, but designing missions so they advance this cause of going to Mars. Heavy use of the International Space Station, maximizing what we can do at ISS to advance this goal was a key part of this plan. And obviously, using robotic missions as much as we can to advance the goal. Advance the science, but also learn things that will be useful when we send humans there. So what we're doing, and this is just the first step, this is going to be an ongoing process over the next year, bringing stakeholders together and trying to chip away at some of the key issues, costing, architecture, pathways. And so I'd be happy, if anybody wants to talk about any of these topics, I'd be happy to talk to you after this. But we're going to be really pushing this with Congress, the administration, and other stakeholders to try to push the message forward. And there is public support. My group also commissioned a poll, also co-commissioned by Boeing, and as well as Phillips and Company of Austin, Texas. But it was during sequestration last year. We want to get a sense of where do Americans feel? Do they support this? And we were really nervous, of course. The sequestration battles were going on. So we were doing contingency planning. We were figuring, what will we do if like 20% of Americans think we should go to Mars and the rest don't? But we were stunned. Over 70% of Americans, and this was a scientific poll done the same way presidential polling's done, believe that we will land on Mars by the early 2030s, and a huge number thought we should double the NASA budget, which we were stunned by that in the middle of a budget battle. The reason for this, in addition to all the great Mars news lately, we did something most polls do not do. We gave budgetary context. We asked, I think a lot of people have heard the anecdotal tales of what people think the NASA budget is. Neil deGrasse Tyson loves giving speeches about how people think it's 10 or 15%. So we asked the question, what percentage of the federal budget do you believe NASA accounts for? We only gave them between 0 and 6%, though. The average answer was 2.5%, which is more than 5 times what the actual budget is. NASA's budget is less than half of 1% of the budget. Once we told them the answer, we asked them the questions. I think that freed them up. You know, it took away the guilt. They realized, oh, this isn't something that's really contributing to the national debt. We should support this. And they even said we should double that. So this is what we've been doing, and trying kind of build a momentum, show them budgetary reality, show them how it's going to benefit humanity, and it really can help in ways that people don't really understand. One of the next steps in this whole Affording Mars process is our conference coming up, Humans to Mars Summit. We're going to be doing a side session to advance some of the Affording Mars topics. And before I forget, I'm going to have some other things to talk about, but I'm also going to, if anybody wants one of these H2M bumper stickers, I'll leave them up back there if you want them. You're welcome to take them. If you want more of them, I can supply them as well. So we'd love you to come to here. It's going to be a great discussion. It will be webcast also. We're hoping to have 100,000 people watching online. We're also coordinating with students around the world, so we're hoping to have 1,000 schools watching this conference as well. So if you have an interest in STEM education, you have students who might want to watch something like this, let me know. So Explore Mars. Now, there are connections, of course, with what this discussion has been. Actually, when a couple years ago, myself and Vlad Truby from Busick Propulsion met with Vint to talk about a project. I'm going to skip through a couple right here because I'm going to get back to this one because this is cool. But I should just go. I should have just done that first. But on this one, CubeSat Competition. Essentially, Busick Propulsion and some others have come up with a way to send 27 CubeSats to build a constellation around Mars. So we've been trying to we're building up the fundraising right now to do a competition, a CubeSat competition, on interesting designs and what we might do. We're going to send 27 CubeSats to build a constellation around Mars, much of which would be communications, because they want to use this to also bolster the deep space network as well. We're also just got involved in a group also using CubeSats, Time Capsule to Mars. MIT, it's a student project MIT's doing, as well as Remarkable Technologies, and UConn is about to come in on this as well. I hope I didn't spoil a secret on the webcast, but MIT has found a remarkable way of sending a CubeSat to Mars very inexpensively using kind of a small electric propulsion device. And what they want to do is actually drop a small spherical, a sphere on Mars with basically data inside a capsule. And this would be a student-led mission. And they're doing a study. MIT is doing a study right now. The report will be out very soon to see if it is as inexpensive as they think. And if so, it'll dramatically lower the cost of getting a small payload to Mars as well. One other thing we're doing, I want to go backwards through this, of course. We're also, because our current missions are not looking for current life on Mars, we've been working with people like Chris McKay over at NASA Ames and Aerojet, and some other folks, find a simple, inexpensive, lightweight approach to look for life on Mars. See if we can get it on one of the upcoming missions. What we came up with was a concept called Exolance, essentially using military technology, penetrators, bunker buster technology to get below the surface. According to Chris McKay, if we're going to find life, we're not going to find it any less, it has to be down like between 1 and 5 meters. So this project is designed to put penetrator probes below a lander, drop them down at about 900 miles per hour, where they will impact, and have top section keeping kind of the communications, the antenna above the soil, while the rest of it with payload goes down and does some tests, see if we can detect life on Mars, microbial life. And so with this, we're hoping to actually build and do a proof of test this year. It's going to cost around $500,000, so we're probably going to be doing a Kickstarter, but also looking for partners because we can do this all, pretty much build it and test it in the Mojave Desert, all within the 2014 if we can get momentum this year. Other things we're doing, since there's been a lot of STEM talk here, we've been partnering with Lockheed, NASA, NIA on the Exploration Design Challenge, challenging students around the country to come up with interesting designs related to Mars. Do a lot of other things, teaching Mars workshops around the country. Done a number of conferences. This one actually was in Strasbourg at International Space University. Women in Mars Conference. Last year's H2M conference, you probably recognize this gentleman right here wearing his Google glasses. And we've also gotten actually involved in a project called Mars World, which is actually an interesting one. It's a huge $1.5 billion real estate development project in Las Vegas where they want to build an enormous dome and all accurate educational, entertainment, and other facilities inside, where we'll be consulting on, trying to build authentic Mars caves. Not that anybody really knows what they really look like, but, try to bring authenticity so we can build excitement through kind of the entertainment world. We also do a lot of policy work, go to the Hill a lot, as much as we can as a 501c3. So we have an awful lot up this year, which kind of connects in many ways to what you guys are doing, in some ways not, but a lot of it does, because what you guys are doing in many ways can enable humans to Mars in the next 20 years. So thank you very much. Any questions? Nope. So if anybody wants these, there is one question. Okay.
Quick question about, I appreciate the Explore Mars Society.
Yes.
A lot of people are talking about a very similar concepts. Can you tell me primarily what the differentiators are?
Well, first off, we're not a membership organization. We came at it a different way, and I used to be involved with them. I actually used to be their executive director for a while. But we decided there was a lot of gaps in the space community, particularly Mars, on trying to really have an impact on policy, bringing people together rather than focusing. We had the same goal. We want to get humans to Mars as quickly as possible, but we wanted to try a different approach in the Mars Society, and we've been very successful. One of our best things is partnerships. Building partnerships with different groups, people who you wouldn't necessarily think would connect, but we had remarkable success bringing people together and just building a much more effective network. And we've had actually significant impact on policy, at least particularly within the space community, and we're beginning to have that also on the Hill right now. So there are similarities, and there's some overlap in people as well from the past. but we're just come at it a different way and are not membership based.
What's the name of the propulsion system from MIT?
I'll have to rack my brains for it, but I'll talk to you if you want to talk to me after, and I can connect you with the people doing the actual propulsion. But it's like these little postage stamp size units. They can put a bunch of them on the back of a CubeSat. Really quite impressive. Anything else? All right. Thank you very much.